Hi there. So today I want to talk to you about Crystal language, which is a Ruby-inspired language. So let's shoot ourselves a bit of Crystal tonight. I was dabbling with it since 3 years ago when I was looking for something more performant and more maybe up-to-date with Ruby than Ruby. And immediately fell in love with it because of its easy Ruby-style syntax and performance, because it's compiled straight to C using LLVM as a backend. I'm seeing a little bit of it. Programming languages for the backend. Definitely Ruby stopped being my favorite because of the performance and architectural decisions, which were fortunate enough. And Crystal definitely took its place along with Elixir, which is loved here, I guess, as well. So, why it's cool? Since some time they had a tagline, fast as C, slick as Ruby, which perfectly given the idea what's inside. The compilation time, since it's compiled language, it's pretty performant. So the compilation times are multiple times lower, or run times are multiple times lower than Ruby in many cases, and many cases of other languages as well. It's not always true, so it depends on the use case as well. But nevertheless, the idea of combining the Ruby-like syntax with compiled backends is definitely is a nice package to have. So to show you perhaps a bit of how similar it is to the Ruby, let us. Okay. So this is pretty well-known Fibonacci function, and it's written in what language was it? Ruby? Both?
JavaScript.
Perhaps both. Let's see what happens. So let's start with all this Ruby. And it's supposed to print the Fibonacci number of 42 and a runtime. How long does it take to actually compute this number using Ruby standard 2.4 some runtime? So, yeah. Thank you. So, 23 seconds for that. And for comparison, let's do the same using Crystal. Okay. Well, I'll show you first the version with which is not actually optimized. And well, that's a difference. Not in the number, but in the runtime. Elapsed time. That is a bit of a difference. And then we can go even further, compiling here in release mode, which will take more because of the LLVM optimizations beneath, but the runtime also seems to acknowledge that. If we want to feel even more adventurous, we could do this, which actually adds the preview multi-threading mode, which comes to just actually landed in Crystal in the recent versions, which gives us even better results. We can change the number of cores on which it runs during runtime. So I'll not go into there because it's like subset secant differences in this case. But nevertheless, it's able to optimize multiple cores from the recent versions. So this one runs in what, 1 second versus versus 20 fruit seconds. So I think that speaks for itself. And this is basically how similar the syntax is. Basically, it's very similar. Crystal is a static, has static typing. So if you really want to, you could define type constraints in the method definitions or elsewhere to actually obtain the wanted type, to check it in the runtime. But if you don't do it, Crystal is smart enough to actually infer the type dynamically. So, for instance, here we have a simple summing function, which is reduced on the array. So running that with Ruby, returns standard compile time error, runtime error, which we know and hate pretty much. And then if we try doing the same in Crystal, we get this information way before during the compile time. So Crystal is smart enough to deduce all the types from the execution. During the compile time, and inform us if basically if there are some conflicting calls. Also in Crystal, as well as in Ruby, you can overload the operators. So this example could run pretty fine if you override the plus operator with string type. But from default, of course, obviously it doesn't do it. So basically, that's about the syntax. It's as close to Ruby as possible, yet still offering the static type. Next thing is basically native C bindings, meaning that you don't need any foreign function interface. You don't need any external interface to communicate with C bindings, so you can very easily and cheaply hook up into whatever library is available already in C world. That doesn't cover C++ though, because C++ function mangling is a bit of a unstandardized turf. And so it's a little bit hard to get reliably. Next thing would be Go-style parallelism, which is, Crystal doesn't have GIL. This is pretty important because the Ruby users suffer from global lock, which doesn't happen on Crystal. So there is no bottleneck there, and fibers are very cheap threads, so to speak. They allow you to cheaply spawn actors, which then can communicate through channels. That was designed after Go, and the channels have blocking and non-blocking property. That depends on how you use them in the code, and they can share memory. Although as a developer, you are responsible for all the locking of the shared pieces. So basically, you still can segfull your app if you don't apply them sensibly. But nevertheless, it's way better than we would have with memory type errors. So that would be about it. In the tests, I think the fibers were tested to go up to several 100,000s without a big problem. So I think this is benchmark are showing that it's pretty good technique. Well, static typing. Let me show you some example. Crystal has also this very nice stuff. It's called Play, which is interactive. Kind of a RAPL, but it's not. It works like it. So basically, as we've seen before, this prevents us from doing the ceiling studies, or being typical, but basically, I just want to show you that you can override variables, they can change types, but as well, you can create units. Unlike in Ruby, Crystal doesn't really have universal integer type. So unlike Ruby, you can't really use one type for everything in terms of numbers. But if you need it, you could use union, which is another specific of language, which basically allows us to keep different types of data under one as a one type, basically. In memory, there are still some problems in multi-threading mode with unions. Because they have different memory layout, but this will also be ironed out, I guess, in soon future. So, what's with these types? We can do overloads.
I can hold the microphone.
No, thank you. That's forward. We do have symbols, as in Ruby, because we all love symbols, right? You can do overloads based on types. You can do method overloads based on types. You can do method overloads based on the arity as well, which leads to way cleaner code. As in Ruby, you would have to do a master case switch with all the types, right? And you can divide it into several methods with proper overloads, handling just one type at a time. That is not needed, because doing the catch-all kind of thing will just match everything, unless there is a more concrete type defined, that is in this case, where this will be just treated as a kind of a fallback method, which is also nice, since you can have defined types for specific methods and then one just handling everything else, everything during the compile time. I mean, from experience, I can tell you this really cleans up a lot of code, basically. When before there were just like blocks of code, just checking for the proper array of types, proper types of the arguments, and even their ordering. Everything is solved in here. Since also, what you can do is you don't need to rely on positional arguments only. You can use name arguments. They'll be matched to the proper names of the arguments as well. Since Ruby is compiled, Crystal is compiled, then you don't really have the introspection or all of the nice runtime stuff that you usually use in scripting languages. So, for instance, as in Ruby, you would use such a construct to define array. In Crystal, these constructs are basically two different constructs between this this. In which case, the first one will be a named tuple, the other one being a regular hash, as we expected. But because of its nature, when we define hash, or basically if you use any other container methods, they are generic. So it's nice, but their size is not known in the compile time. And if you use unions, which is pretty handy at the times, you still don't know the exact type of the element which is being held in an array, because it can be any of the matching types. So their compile time equivalents are tuple to array and named tuple to hash, which is basically the same, but with having the compile time values being known already during compile time. So the arguments of a method are also, they could be defined as tuple. Oh, is it the end already? So, in this case, as in Ruby, you would just convert all the arguments into a tuple.
Can I have like a quick question?
Sure.
The reasons the lines between 19 and 25 do not have any output is because they don't get compiled. They are compiled out because they are never called, right?
No, it's because they don't return anything. Because in Ruby, as far as I remember, the definitions are also expressions, so they return something actually, the symbol of defined method, right? And here they don't. Simply all of these, the results on the right are the results of the returned output from these calls.
Okay.
And I think it's not shown here. Yeah, there is also the output. So it's not really handy. Okay. So we now know a bit about types. So let's get to something more interesting, something like the HTTP server. Pretty simple thing to do, right? Not in Ruby. You have to go deep down to TCP and handling all of the HTTP protocol basically by hand, because there are no standard lib libraries to handle that for us. So of course, there's a lot of gems which do it, of course, but there are external dependency for the big part, they're also pretty huge. So sometimes we don't want to import such big piece of functionality. So this is how that looks in Crystal. You already have a concept of middleware, which is being injected into the passed to the server. So basically, this is the equivalent of a rack in Ruby world, but without rack already. And standard lib is was not direct. It is not a direct port of Ruby. So it's more of a like it's being influenced by it. But big parts of it were just basically being rewritten for more better developer experience, which definitely you can. I mean, I can assure you it's way better than Ruby's library. There are some, of course, differences and oddities like Ruby include versus Crystal includes, which basically is a language typo on the math side, I guess, and just happens to be with us for all these years. So this also was fixed or math. So yeah, standard library is a really big piece of the Crystal ecosystem, which is basically a big hell. Yeah. Well, yeah, because there is no runtime reflection. We, in Crystal World, we ended up with some kind of a macro magic, which is basically supposed to do similar things and happens to deliver on a promise in most of the cases. And basically macros are compile time code, which macros are being executed in the first pass by the compiler. So the code inserted by the macros is actually just a text code, which is being inserted into the source code of the program before being actually compiled. It's divided into different steps, so you have hooks allowing you to extend classes and modules based on them being included, extended, basically known from the Ruby world as well. And there is a hook that runs at the end of the whole compiler pass, which allows you to finish off your macro magic if you need one. And this is basically needed for more dynamic things, like for instance, this macro is made just for that, basically for being able to inject the named tuple, meaning the argument, and assign them automatically as the local variables by using the variables themselves or by using setters if they're defined. So to be able to do it easily, well, there is bit of this magic involved, which basically during the compile time reveals all the methods which are ending with the equal sign and have just one argument. So we know that by that they ought to be setters. So we first check do we have any setters matching that property. If not, then we do the same on the instance variables. So basically, this is kind of a fallback in case we want to initialize some private, not exposed for variables directly. And well, this is a price I take to be paid for having a compiled language with such dynamic features. So a lot of the problems relating to the dynamic nature you can solve by macros. Others you can solve by different design, and others you just can't. So you just have to live with them. But it's a pretty nice lifestyle. I complain myself. So yeah. Let me get back to the order. So okay, so once we know we can do some pretty funky micro magic, there are also shards, which are basically the gems for crystal. And in comparison to bundler and gems ecosystem, the shards are designed to be decentralized completely. So there is no like there are directories of shards, but you don't have a really kind of a repo that holds the like the Ruby gems, for instance, or NPM. All the shards are hosted in the public spaces, or basically Git repositories or other repositories, if someone wants to. And they are designed also to be as easy as simple to use to work with as the Ruby gems. So basically, the only thing you need to do is to declare the dependency in the shard YAML file. And well, install dependency and just require it, like in Ruby, so no big deal. Works out of the box. A lot of Ruby also nice ideas like opening classes and everything is also there, so this is also good and bad stuff because you can break other people's code, but this is well, live dangerously kind of thing. Another thing worth saying is also that there is no such thing as a nil. I mean, nil is a type, so there is no accidentally just going onto it. You can always define the type you want to, basically whether you want it nillable or not. Also known from Swift, for instance. They're already pretty used, pretty well renowned frameworks for Crystal, which every one of them is taking the inspiration from some of the Ruby framework. I mean, Camel is just a bare bones, basically kind of a Sinatra, and other Rails. Lucky are more Rails way, not design. And there are many shards already available, and many of them are really in good shape, production ready. So ecosystem is there and it's growing. It's of course just a fracture of what Ruby ecosystem is at the moment, but nevertheless it's getting there hopefully, and it's expanding from month to month and year to year. So it looks good. It's being also maintained. So well, do we want to use it in production? So yeah, I'll use the. My favorite, saying from our industry. Well, it depends on your needs, basically, and on your level of bravery and dedication to maintaining the code. Because, well, yes, standalib API is in constant flux, and really it does change from version to version in the basic stuff. Recently, for instance, there was a big change of renaming very three-letter method, which is not big in itself, but basically it was a time new method, which is pretty known, and time now, I'm sorry. And time now was renamed to time etc, and there was also time local to make the developer aware actually which time do they really want, because time now doesn't really says a lot about in which time zone is now. I mean, guessing it's now it's in our time zone, but it's not maybe crystal clear enough. So it was. It was renamed some time ago, causing a big stir in the community. Fortunately, recently there were also added deprecations as a annotation in a language, because it also has annotations in a way of Java, so it doesn't look that nice perhaps, but that's pretty useful at the time. So at the moment, a lot of the methods are deprecated before they will be really removed from the API, fortunately. although it happens infrequently since the API is below the 1.0 level. So basically, core members are pretty open to breaking the API often than not. So you have to keep this in mind. I have to tell that while this API, what I've written sounds perhaps a little bit bad, but the reality is not really that dramatic. That updates from version to version are usually small and usually pretty cosmetic. I think maybe during 3 years of my experience with Crystal, maybe 3 times I had a situation where I really had to spend a couple of hours to rework the code under the new APIs or basically circumstances. So I would say not that bad, really. But you have to have someone who will do it, or unless you'll just be locked into some old Crystal version for some future. So, yeah. The second point is a little bit tricky because it happens that Crystal segfolds and there are some internal compiler errors that happen as well. Some of them they're random, so some of them they're edge cases. So there are bugs to be expected in general. They are pretty corner cased and usually from my experience you can manage to avoid them, to find some way to get over them. Nevertheless, well, you can expect them, that's for sure. Big code bases also will suffer once you'll hit certain threshold. Basically, compilation times will go high and you will get low during the time, that's for sure. And incremental compilation is a hot topic. Hopefully, will be done in some time, but at the moment the problem is the type inference, to keep the language really flexible and without typing, with basically the inference, allowing you to omit the types at the times you want. This comes at the cost of the incremental compilation, which is not possible with this at the moment. So depending on how big is the project, you might want to just split it into smaller parts, some microservices for which Crystal just works pretty well, or maybe choose another stack. Windows is soon to be done. It's in the works for the last couple of years, I think, but it comes to an end. A lot of the to-do list is already done, and with the introduction of the multi-threading, this is the next thing on the plate to be done, and well, it's happening. So I don't want to throw any dates, but maybe in some months the Windows will be supported as a first-class citizen. At the moment, it works, of course, on Linux and Macs, and it supports the 64-bit architecture and some of the ARMs. The ARMs are a little bit experimental, so you have to cross-compile the project, and things can get a little buggy at the times, but nevertheless, well, for the adventurous, it's there. And since it's a compiled language, and well, no one came with the good idea to write a REPL for it. That would be a true REPL, basically. So even though there are some other ways, basically there is like fake REPL, which helps a bit, and there is Crystal Play, of course. So it's not that bad, but the REPL itself, it's not bad. Well, these companies already decided that Crystal is ready to go to production. They use it in everyday operations, and they actually, they have products that, as far as I can tell from the other side of the internet, they seem like they're working and they're earning some money. So I think that's some of the validation that you can do it. Well, thank you. Any questions?
Hi, thanks a lot for the presentations. From some point of view, I know it's almost your first presentation. So
Yes, it is my first presentation, so yeah.
Great, congrats for that. Can you tell me, do you know when version 1.0 is going to be there?
That's probably the first question everyone asks. No, I don't. And I'm not sure anyone does.
Okay, so I'll go with the second question everyone asks. What about web frameworks? Are there any?
Let me go back.
Okay.
And all of them, they are, I mean, the stars, they don't need to, of course, tell you any story, but they are already years in development and used, for instance, Amber, second from the list, is used by this Nikola Motor Corporation, and they put these infotainment systems in their trucks and electric vehicles, on which this infotainment system on the back end actually runs Crystal with Amber, handling the HTTP. The rest being, I guess, the JavaScript or whatever on the front end, which displays great dashboard for the user. So yes. And also, it's very easy to write your own. I mean, I'm not saying it's a good idea, but it's easy to write your own, stack on top of the Crystal standard library, because it's really very easy and performant, and you don't really need too much aside it, unless you want to go into the full-blown frameworks with all the creature comforts. Then, of course, that goes. So,
Okay, excellent. If there are no more questions, then thank you again.
thank you.